So welcome on the Lightning Talk speakers, and we're not going to introduce them individually because that takes too long. So um, do we have the first one up here? Slide. We don't see the slide down here. We see, there we go. Huh?
Also, have some levity with these in the audience. Like sometimes, whether auto advancing or technical or just fumbling with words, like show some love to our speakers. Ignites are hard. Like I said, it's the format is really fun, but it's also can be nerve wracking. So kudos to you for doing this, and audience, yeah, show some love.
This really is a great vehicle for people to get some experience speaking who haven't done much of it before. So, I see me. Oh, here we go. All right. Welcome to my talk. This is How to Succeed for Outsiders and Noobs. This is aimed mostly at people who may not have much experience in tech, much experience in the corporate world. It's also useful for people who are mentoring people who haven't had much experience in tech. So keep that in mind. Who am I? Silver Bowen. I am a senior staff engineer. Just got a promotion. Thank you very much. I did a bunch of stuff in my early life, and eventually I ended up being a tech bro. How did I do that? I didn't have the tech background, but I got it, and I made things happen. So I guess the first thing to keep in mind is that what worked for me isn't necessarily going to work for you. We're all different people, so I'm not trying to give a series of steps or a prescriptive path. What I'm trying to present is a system of thought. That starts with where we are right now. We're at DevOps days. When I started my career early on, I was lucky enough to come to these kinds of conventions and start learning about Lean and Agile and DevOps and that kind of stuff. And I used it to inform my career progress. If you look at this, if the nurse is the tech career that I desperately wanted about 10 years ago, and the brain thingy guy, whatever he is me, then this is pretty accurate to about how I felt maybe 10 years ago when I was really trying to break in and had no idea what to do. So I took these DevOps principles that we learn, and I said, okay, I'm using this to improve corporate culture, right? I'm using this to make the workspace better and to make my life in the workspace better. So what if I bring that down from a macro level to a micro level and start applying all of these principles and procedures and stuff like that to my own personal life? We've only got 5 minutes, so I can't cover everything. So maybe I need to get this a little closer to my mouth. So we're just going to do continuous improvement, because this is kind of the granddaddy of them all, like the foundational principle. So you make a plan, you do what your plan says you're going to do, you see what happens, and then you retrospect on that and figure out what to do next based on what happened. You're trying to get yourself into a virtuous cycle where you succeed, and because you succeed, you want to do the thing more, and because you do the thing more, you get better at it and succeed more and more, as opposed to a vicious cycle where things just kind of spiral downward. You're trying to build up this momentum so that every time you succeed, you stack a little bit more value on top of things, right? You've got something in your background that is magical, that is different from the rest of the world, and these differences in the corporate world are very valuable. That novelty is very valuable. Whatever it is, I don't know what it is, I don't know what's special about you, but there's something you bring that nobody else has thought of, that you can work with, right? So look at one of those things, and it's important to be specific here. If you scatter your effort, you're casting too wide of a stream. So pick one thing that you think you're good at, one of your strengths, start working on that, start seeing how you can leverage that strength in the corporate world. For me, it was being able to explain technical things to non-technical people. So as an example, scientific method, question, research, do your stuff, share it, do it again. It's a cycle. This is the same cycle as continuous improvement. It's what we've used to go from, caveman days to where we are now. So again, getting yourself into that cycle, taking one of your strengths, and we're not really too worried about weaknesses. Weaknesses, maybe you can fix them, maybe you can't, but your strengths are where you're going to make an impact. So take your strength, put your strength through the cycle, do something, see what happens. Then the really important part about it is you have to go back and you have to look at what you did. You have to understand, how did that work or not work? Why did I fail? Why did I succeed? How can I reinforce that success and keep that cycle moving upward, right? dry mouth, man. And once you get that cycle kind of turning on its own, then you're in a good place to just let things ride out. And you just keep putting that effort in and let that feedback loop develop. You only really have to start this process once. Once you kick it off, once you start following it, it's gonna run on its own. So, which is also, if it's a bad feedback cycle, that's, break the cycle, same kind of thing. One more, this is the design cycle, but you can see it's the same thing over again. You do something, you see what happens, and then you think about what happened and figure out what you can do to either make that thing that happened happen again, happen better, or not happen again. You're just trying to get that iteration going, trying to stack up these slivers of value, getting better and better until you hit this beautiful hockey curve, right? All of a sudden you've gone from, oh, it's okay, to, wow, look where I am now. You're in the heights, things are going great. And you almost won't feel that change. You'll just one day be like, wow, I did all this stuff, that's cool. Because you got that cycle working for you. This is the last one here. It's the OODA loop. Air Force Colonel John Boyd, how he taught fighter pilots to win in dogfights. Hopefully you're never in a dogfight. But this is I just wanted to show this one because this is really where it all started. It's in, Gladwell's book and a lot of stuff like that. But, in all places, look for a cycle, get feedback working for you. It's important to know that everybody has imposter syndrome. We all have it. Everybody deals with it. It doesn't matter. How you feel about yourself doesn't matter. What matters is you find a plan and you stick to the plan regardless of how you feel, and you'll get there. That's really all it takes. So what have we talked about? Circle, go, burr, right? That's all we're really trying to do. Get a feedback cycle working for you, make it happen, and you will get there. Hopefully this inspires you a little bit also to look at some of the other principles we use, things like continuous delivery, things like infrastructure as code, right? How can you use this in your own life to succeed? I don't think we're doing TalkPay here, but if we do TalkPay, you should definitely go to it. If you ever get a chance to see it, you should go to it. It's really useful for determining the value of your skills in the marketplace, and people sharing about how much they make is really valuable for everybody. And that's it. That's my talk. Thanks for listening. If there's anything that I can do to improve this talk, anything you liked about it, any feedback at all that you can share with me, I would absolutely appreciate it. It's very valuable. Thank you.
All right, thank you, sir. All right, hello everyone. So first of all, my apologies. My allergies have been body slamming me this whole week, so I've been chaining cough drops. So hopefully I can make 5 minutes without coughing, but we'll see. All right, good to go. All right, so I'm here to tell you about a little feature, a new feature that went J in Docker called Docker Bake. It's something that I stumbled upon while I was working on something else that was related. And so I think it's pretty neat. It's kind of niche, but it might be valuable for some of y'all out there. So the thing that I was looking at in particular was updating the way that we were passing secret values in from the environment into our containers. Because like I know historically that passing them directly in through like build orgs or environment variables is not ideal. Sometimes you might leave traces of those secrets in the resulting containers, so not ideal. So I was looking at what the latest and greatest way for passing in secrets are, and Docker has a new syntax for secrets that I'll show here later. But when I was looking at it in the documentation, it also mentioned something called like a Docker Bake syntax, and I was like, oh, this is interesting. I haven't heard of this before. What is this? And so I went down a bit of a rabbit hole, and I'll share with you a couple of things that I found out here. So the gist of it is that Docker Bake is just a new-ish way of building containers, and it's got a few different ways of defining those definitions, either with YAML, JSON, or even HCL for my Terraform and OpenTofu stands out there. And it does give you a couple of new capabilities. So first I'm going to tell you about the three kind of main things of a Docker Bake file, but I'm going to show you a side-by-side example real quick first. So like here is like a before of how we were passing in all the different build args we needed for building our container, passing in our register user and password so you can get the dependencies that you need while you're building your software, as well as a few other metadata pieces versus Docker Bake, where you don't seem to have any of that. And I'll show you why that is in a moment here. So the three main parts of a Docker Bake file. One is variables that defines the inputs that you need for your container, all of the values that you're passing in. Second is targets, which defines the actual containers. And you'll see a lot of similarities to like a Docker file there. And then groups, which gives you the ability to combine things in different ways and output things based on your scenario. So here's a little bit of code for variables. So I've got two options. One is just a simple one that shows just a default empty value. And the other, and you'll notice if you can see the code here, there's a little bit of a validation block here. And this is one of the neat things about Docker Bake that you get over just doing things with Docker build through Dockerfile. Like you can actually have the ability to do validations, and like the validations that it supports are relatively straightforward. Mostly it's checking for like nullity, so does something exist, or checking the range, is a value greater than amount. But you can even pass in a regex just in case you want to go that route. But the nice thing about these is that they're defined and overridden from the environment by default, and so you don't have to pass them in as build args. And then here's a look at the target, and like you can kind of see that a lot of this looks very similar to the kind of things that you would pass into a Docker build command. You got your context, your Dockerfile platforms. You'll notice that that's an array, so you can pass in multiple platforms. And then that's the new secret syntax that I found that makes sure that your secrets don't leak into the resulting container. So it's just all the stuff that you would expect to see with some syntacture for permutations. The secret syntax is definitely new, and it kind of mirrors the complexity of the newer volume syntax, but it does work pretty well. And it also even allows you to do inheritance between targets in case you have particularly complicated things that you need to build. So next, let's talk about groups. So groups are not strictly speaking required. You don't actually have to define a group, but if you don't define a group, you will have to specify the target that you want to build. And so I think that a good thing to do is at least to define a default group. That way, your users won't have to pass that in themselves. And next, let's go back to the side-by-side example. So you'll see now there's nothing magic that's going on here. Inside our bake file, we've basically exposed all of these variables that are getting interpolated into our resulting containers. And that's really where all of the complexity is. It lives now inside of the bake file instead of living in command line arguments. Okay, so, and you might say that this maybe feels a little bit familiar. It might feel familiar to another Docker tool that exists, where instead of passing a bunch of arguments on a command line, then you can do it through like a definition file. And you, of course, would be right that this does feel just like Docker Compose, right? And so the kind of short thing is that Docker Bake is to Docker build as Docker Compose is to Docker run. So like, just like with Compose, like you don't technically need Compose if you wanted to run a container, but you know, it makes things easier when you have like multi-container applications that you want to run at the same time. And so Bake gives you a lot of that similar lift without having to pass a bunch of arguments around. So yeah, like and like Compose doesn't do anything that you can't do with run, but it's nice. It gives you a consistent way for defining the application layout. And like I mentioned before, it can be really helpful if you have multiple containers that you need to orchestrate. And that really is basically what Bake gives you. So like Bake isn't different. It just ends up being a bit easier. You notice the asterisk there, and I'll talk about that also, which is that, and this shouldn't be a problem for most people, but Bake does require that you use the BuildX build engine. And when my slide advances, I'll tell you some more stuff about that. But the BuildX build engine has been the default since mid-2023. That's when it became the default. You're probably using it now, and it does, if you aren't specifically aware of it, does have some nice things about context efficiency and multi-platform builds and caching improvements. I have definitely been in previous jobs at places where we had versions of Docker that were running from like 2016, which was scary. But most of you will probably be able to take advantage of this if you would like. So like in the end, like, do you need Bake? I mean, not really. It does make certain scenarios easier, specifically if you're building a ton of containers off of like a single Docker file. Like you've got a lot of permutations for different platforms or different dependencies that you need to support. but it's pretty nice. You know, like you get the ability to define your build through a nice configuration language. Like being able to use HCL is nice. I like it certainly over something like YAML or JSON. So it's nice. And so if that seems like something that's interesting to you, I definitely recommend checking out. It's nice and it's pretty easy to use. So with that, I'll bid you all to do. Thank you.
All right, so I'm David Burkhalter. I'm a platform engineer, and our team is in charge of the developer portal for our company. And I'm kind of talk about how we use design thinking and the principles in it to help drive adoption to our developer portal. So as an engineer, we think we're the best at everything, and we know that we can build this perfect system, and we kind of have the philosophy that if we build it, they will come. But even though we think that at the start, how do we know that what we're building is what the customer actually needs? So we need to know that it's a symbiotic relationship instead of being aggressive with our users and forcing conversion upon them. So if we try and take our users and tell them you have to use our platform, there's no other way, it builds resentment and it drives an antagonistic relationship instead of kind of like the symbiosis that we hope to have between the platform team and the application team. So one of the ways that we can help do this is using design thinking. So design thinking consists of empathize, define, ideate, prototype, test, and then implement. So we all love cycles, and this is kind of like a nice little flow to discover user problems and solve them. So the first step is empathize, and what this really requires is finding out what are our users doing, what are the day-to-day challenges, and how can we help them? Because that's going to motivate them to want to use our platform and become people who will help spread it. So our customers in particular are software engineers. So we need to go and observe throughout the life cycle of their day-to-day workflow. So that includes how are they writing code, how are they building code, how are they testing code, how are they releasing code. So basically, sit down with your users and then look over their entire workflow and see what are the different points that they have that you think might be better. So now we have a whole bunch of different opportunities that have been kind of bubbled up from this interaction, and now we need to define what are these problem statements and how can we help them with them. So in order to make our users happy, we need to know what these issues are and what we can do to solve them. So what do they want? What do they really, really want? If we can solve this issue, then users would be happy to use our platform instead of feeling compelled and forced. So this is how we're going to try and drive this organic interaction. So now we are compiling all these problems, all these issues, all these statements, and seeing what are we encountering in our organization. So for our organization, the big problem was where's Kubernetes? So helping teams create Kubernetes clusters, how they structure them, how they organize them was the big problem statement for us. So we decided if we can help them create and make these Kubernetes clusters, that's a good way to drive engagement with our platform. So now we have this problem statement they're trying to solve. Now we need to find out how we're going to solve it. So ideate is basically the brainstorming stage where you sit down with your team and you throw a bunch of ideas at the wall and you see if any of them stick. Because truly innovative solutions are not obvious, because if they were, then somebody would already have thought of them. So you need to go out there and find all these crazy ideas. Who would think that it would take a bunch of oil workers to blow up an asteroid in space with a nuclear bomb? Nobody thought about that, but it's just crazy enough it might work. So within your organization, sit down and see what are the different technologies that we can combine together to drive these solutions. So we had Cluster API, Argo CD, EKS, EC2, GitHub Actions, and we kind of had to say out of this Lego box of different bricks that we could use to solve the problem of creating these Kubernetes clusters, what's the best way for us to do it? So within your internal team, work together to collaborate on the solution, and then now you're going to start prototyping it. So far, all of this has been done on pen and paper, and now we need to put it into action. So rapidly develop and run into any issues that you might find, because that is where you will actually create the solution. So through the process of making it real is how you discover what the best path forward is. So if you run into an issue and it's a blocker, just keep going, iterate around it, and try and get this MVP out as fast as possible, because what you're trying to do is get a quick cycle to find out if it's the actual issue that you're currently solving, because the further away you are from the users, the worse it is. So now you're testing your solution, you have your MVP, and you can go back to the original group or any other kind of like alpha users and say, like, here we have what we've been doing, and we want to see if it has actually solved your problem, because we had our idea of how to solve it, and you might have your own. So we've got to bring it back. And is it all right? So through this feedback that we get from the users, we can discover if our intentions were correct and we actually did solve their problems. So now that we've done this in, say like a staging or a test environment that we gave them access to, we need to bring it to the wider audience, because design that is not delivered is nothing. So implementing is the last stage of the process, and it's the most important, because now that you have solved this problem, you need to go out to the wider audience and broadcast it. So you need to do sprint demo reviews, you need to do kind of collaborative sit-down sessions, or maybe even have like a Slack channel where you just like post updates and you have office hours and say like, hey, like next Wednesday, let's get together, I'll help you implement this feature, like let us help you deploy some Kubernetes clusters, and then see how easy the interaction is, and it'll invite users to come back and use you even more. So, dude, sweet. Now we have user feedback-driven development. So we've solved their problems. They're happy to use us. They've realized that we've built trust with them. They want to use us in the future. They realize that we're a solution center as opposed to like a problem center. And they're looking forward to any future interactions we might have. So now it kind of goes back to the start of the cycle, where we've delivered this feature, we've built this trust within teams. Now we can sit down with new teams, empathize with them, find their problems, define them, make new innovative solutions, prototype them, test them, implement them. So I think if we add in some design thinking to our delivery process, it'll help create a more collaborative environment for both the users and the platform teams, and make everybody happy.
I like how David thinks Armageddon is a documentary. So, and that he knows what Windows 3.1 is. So, you ready?
Good afternoon, everyone. Hope everyone is doing good. So my name is Nihar, and I'm a cloud support engineer at Amazon AWS. And I'm actually a subject matter expert in multiple deployment services at AWS. So I'm here to present my talk about how I wrote perfect CloudFormation and then learned that infrastructure is just only half the battle. So it's about the journey from technical perfection to organizational reality in the world of infrastructure as a code. So during my journey, I've been working with AWS almost 5 years, and I have written hundreds of templates and worked with hundreds of customers in writing hundreds of templates. During this journey, I learned that infrastructure is just writing a code is only half the battle. It's basically you can write very great code, but the people using the code need to be understanding the logic behind it, how they need to implement it, the background, how they can follow the structure. So it's about the people, it's not just about the code. So the technical problems were easy actually. So solving the syntax errors, validations, drift detections, remediations, creating the reusable and modular codes, those were easy. But the actual hard things were getting the teams to adopt the code, establishing the consistent best practices, and establishing clear ownership models, creating governance, and creating the knowledge sharing documents so that other people can reference and implement the templates in their teams. So there are 3 stories that changed everything. So ownership chaos. So basically, when we were writing the templates and having it delivered to the other teams, they were just using it, but they were not taking the ownership. And when something is broken, they were in chaos, like whom do we reach out? How do we solve this? So it was a complete loss, ownership chaos. Then there was knowledge silos. There was no proper documentations, and the code, writing code is not enough. You need to maintain proper documentation. So that is the other thing, and maintaining the smart governance. So basically, if you write the code and have teams use it, they can just launch the templates, and you will end up having a 100K or 1000K bill. So you need to have put smart guardrails and implement loops, feedback loops, so that the teams can follow that, and you don't end up having a huge bill. So having clear ownership, shared knowledge, and smart governance play key role when you are building the infrastructure as code. So the real work you think isn't what you think. So basically, you can just copy paste the templates, use someone written templates, Terraform modules, pipeline configurations, and so and so. But what you cannot copy paste or implement is basically the trust between the teams, the ownership, the governance, the alignment on best practices. So it comes with the best practices. The teams needs to follow this and implement that such that their entire team and the company can be successful when you are having this. So the key takeaway from this talk is basically like the code is the easy part. You can write it and use it, but the people using it needs to understand the code and the functionalities behind it, so they can take the ownership and follow the governance and have the knowledge sharing documents prepared so that others can use it. The hard part is building the culture. So you need to build a culture so that your teams can effectively use the template that you have written. And it's about focusing on the people, infrastructure, not just infrastructure as code. So you can basically ready to apply this by, you can implement this basically by auditing your current state, like how your teams are doing, how you are copying the code, how they are using the templates written by others, and what happens if something breaks down in the middle of the night, whom to reach out. So all this can be implemented by following knowledge silos, following the knowledge documentations that implemented, creating governance and guardrails, and you can start small, think big, pick one project or team, and then establish the clear ownership and document the best practices and create the governance. That way, you can also measure how your team is delivering the success, and that's when you can actually say real transformation has happened, and you can then say like you're also having a better infrastructure as a team and also as an infrastructure as code. So yeah, that's pretty much about my talk, and I hope you have a wonderful rest of your day. Thank you, guys.
For this next one, we have a little technical setup, so I'm going to wait until I get the thumbs up from our AV specialist. Also, due to some things in the slide, we're going to have to self-manage this one. So if Mohammad goes on for 2 minutes a slide, you can make your faces. So. But no, I've got a hook and a timer, so he's going to be self-managed. All right.
Awesome, thank you. It's really great to be in Dallas, but I have to admit, I'm a Commanders fan. But one thing that we both know is how hard it is to do a rebuild. And so just like in football, in DevOps, you have to get the fundamentals right. You have to make sure that you handle things like compliance. Before we talk more about that, let me introduce myself. My name is Mohammad. I'm a director of software engineering. Immigrated to the US at 8 years old. My first job was at Subway. Today I work in developer platforms, and I'm equally passionate about people, tech, and systems. And I have to admit, I do love a lot of bad TV that my wife and I get to enjoy together as well. So let me introduce Erin. So Erin is a full-stack developer, and she waits for a lot of build times. She waits for a lot of black box behavior. She doesn't understand compliance or rules very deeply. And this is a struggle that isn't just pertinent to Erin. This is a struggle that developers at large face. Erin represents developers at large. More specifically, her reality is numerous tools, COTS, homegrown. They must exist so that we can securely deploy and manage code, but they're also not often seamlessly integrated, and it's really hard to know how to stay fully compliant. And Erin doesn't really care. She just wants to ship code. So Forecast, which is what we'll talk about moving forward, addresses two main concerns: long build times and delays, and also feedback loops that take time away from her, where she goes and gets coffee, comes back, then gets that information. So this is Forecast in action, and this is why I needed a clicker and the PPT. So on the left, you are actually seeing similar information represented in Jenkins. And on the right, you've got it in IDE with underlying in line to the file where the error happens. This works seamlessly for all of the large IDEs that are available, and it happens well before the code even gets to the build stage. This is built in TypeScript, and for VS Code at Capital One, we have 69% of the developers who are developing in VS Code. So a combination of TypeScript and VS Code, building this central business logic enabled us to scale this across multiple IDEs. Here's an example of this in JetBrains. So leveraging the Kotlin multi-platform write once, output multiple times mechanism, we were able to codify this business logic in a way that allowed us to scale across IDEs. In its core, though, it's actually a CLI-first tool. The CLI written in Go with Kong is where we integrate with all of the various compliance systems and linters that exist at the company that our team does not manage or own, but those are guardrails that developers must be compliant in. So you can see here how all of those checks are running in the CLI, and then up the stack as we build in the IDE, we simply communicate through the CLI layer and also a long-running daemon process in an engine. So that's all great, but you need to see a lot of this information really clearly. This is where UX and product design thinking is really, really important. So you can see here through these lines how multiple systems, whether it's static code analysis or some of the homegrown tools like CloudPre and Avenue, all of those detections are being shared. And you're also seeing, in this case, they're all errors, but you could have warnings or informational cases as well. So you get a sense for how to prioritize and manage the load of like multiple findings. Our North Star has always been compliance as easy as spell check, the way you might consider grammar or spelling in a word processor. Signals so far, whether it's adoption or value measurements or feedback surveys, have been clear that we're headed in the right direction. But I actually want to move away from this product and forecast and shift left altogether and talk about like what makes something a good idea. A good idea is usually something that takes seamless intelligence, buries a lot of complexity that a user or a developer doesn't even have to see. A good idea is actually about a breakthrough change, a paradigm shift, a 0 to 1. A 1 to N would be a tweak to existing systems, making them slightly more efficient, making them a little bit more better at what they do. But when you want to make larger changes, systematic changes, you really want to strive for a 0 to 1 case. Take the iPhone, for instance. A lot of complexity buried, but the experience is forefront. The usability, the ease is forefront. But I also want to shift from a good idea to execution. So this curve here is a curve about what it takes to get to mastery. There's a really good book called Mindset that talks about what it takes to accomplish things. And this is true in careers. This is true in our personal lives. This is true certainly in building products. So this curve applies ubiquitously to the human condition, to solving problems, to learning. But it also always comes with a dip. The dip is where you're actually doing a lot more work, but the payoff isn't there. And in fact, in many cases, you're getting less payoff than those initial early wins that you had. This is where it takes grit, resilience, and sticking to it. And the dip is also very, very painful. In the famous words of Ray Dalio, he has said that pain plus reflection equals progress. And so that's really, really important to remember when you're doing something brand new, a 0 to 1. It's actually a sign that you're onto something. It's a sign to persevere, not necessarily back off. This is actually a real example of our dip in our product journey, from architectural redesigns to refactors to rebranding to executive buy-in and so forth. The next thing is, well, how do you decide you're onto a good idea? Well, every product has to answer some fundamental questions. Is it 0 to 1 or 1 to N? Is this the right time? Timing is very important. Are you actually a niche value product in a smaller market, or are you trying to boil the ocean? Do you have the right team? Talent and alignment is super important. Finally, what does it take to deliver a product isn't just the product itself, but instead the go-to-market strategy, the scaling strategy, the support strategy. And then I'll leave you all with just a couple of really quick slides. So forecast found an error. This is circling back to our earlier set of slides. Now what? Well, what we're trying to do next is actually go from a place of information aggregation to developers fixing and getting remediation in line. That has a number of dimensions: context-aware, autocompletes, auto-remediation of security groups, to chat and AI-powered. I just want to double-click on chat for a moment. So we're augmenting this with another product, Omnibot, that's going to be embedded in the IDE as chat, a little bit like Copilot Chat or other chat offerings, but with Capital One context. This is a real example of a case where you're seeing a static finding on the right with the red squiggly, and the developer is highlighting that, and on the left, they're interacting with Omnibot to say, what do I do? And it responds with, what would you do in this situation? So you go beyond just information detection to remediation guidance. Finally, I want to leave you with, tools aren't just tools. They actually empower developers and people to solve problems. And the data is very clear. Organizations that invest in products and platforms for developers see up to 50% in productivity and up to 30% reduction in turnover and attrition rate. So thank you so much, Dallas, and go Commanders.